All right, so while we're talking about IP addresses, I know there's a mechanism that hands me an address on a network.
Correct.
You want to talk about it just a little bit?
Sure. Well, so from the OSI, we talked about what's, right? So now we're getting over into the areas of what I call the hows. So just as a refresher, the OSI tells us what we need to do to move data. Protocols are basically rule sets that govern how we do that. So we know from layer 3, I need to have an IP address if I want to be in a network or communicate to other networks. Now, how we do that, I think you even mentioned that you can know how to set a static IP address on your computer. Well, there's another option, and this other option is where the network gives us an available address in its network range. And what this is called is Dynamic Host Configuration Protocol, or DHCP. How the sequence of operations, you take your computer, you plug it into the network jack, and what happens is a DHCP server, something that's in that network, again, a network node, it takes a available IP address that hasn't been used by another computer, and it will assign that, or it will lend it to you. In fact, the term is we will lease a IP address to the individual node. So how this works is you plug in and it happens. It's important to understand that there's a difference between static addressing and automatic addressing in this case, because if you static address, there's a chance that you might not be putting in the right numerics. So you might, goof up a number or something, and now you're in the network, but not in the network because you're not of the same network identities and you can't talk to anything. So what a DHCP server will do is it says, hey, I've got this range of IP addresses, and any host that wants to join, I will loan them an address, and now they can communicate in that domain. So that's DHCP. And again, like you said, the other option would be to statically assign. There's also other different forms of communication protocols that happen here because it's hard, if you will, to remember IP addresses. You and I, we don't speak in IP addresses.
No.
So what we do is we can convert IP addresses into what we call domains. And a domain would allow us to communicate to common areas, but not using the IP identities to do that. So domain name system, or DNS, was developed that we could decentralize and do a conversion factor of the domain itself or the IP address to something that you and I could recognize. Take Crestron as an example. When we want to go to the Crestron website, we don't type in the IP address of the Crestron website. We type in crestron.com. So what happens there is it resolves through domain main system from the word crestron.com to the IP address of where we're located.
Yeah, I've always kind of thought as DNS is like the phone book of the internet.
Absolutely, yeah. You don't know the phone number of the organization you're looking for, but you know the name of it.
Yeah,
right. So if you're looking for dry cleaning.
Yeah, as long as I can spell it correctly.
Yeah, if you can spell it correctly, it will resolve it for you. And it's fascinating. You had mentioned before about trace routing. Depending on where you are, the IP address to get to specific areas changes. So, like, for example, if I want to go to Google and I'm in my office, I can see through the trace route what the IP address of Google is. And if I travel across the country or across the world, that address is going to change. But what didn't change?
The name.
The name didn't change. So DNS helps us there. So that's a good one for us to leverage often.
So if you remember earlier, I was talking about the spec sheets I was looking at, and I would see like L2 and L3, and then I said, and all this stuff. There is like lists and lists of the protocols that are supported by these network devices.
Yeah, that's correct. I mean, there's more protocols than you could shake a stick at. We have protocols for everything. If we're doing specific communication styles, like SMTP, Simple Mail Transport Protocol. You name it, there's protocols. We even have protocols for transferring files. Oddly enough, File Transfer Protocol, or FTP.
Yeah, I noticed that on a piece of software we use often called Master Installer. It just manages all the Crestron applications because we recently moved from FTP to SFTP.
Correct. What we did, based on the fact that we want to be, aware and proactive on security, File Transfer Protocol does have an option to do secure File Transfer Protocol, SFTP, like you just mentioned, which they do the same file transfer protocol itself, but then they add this layer through what's called TLS, or Transport Layer Security, or even SSL, secure socket layer, they add this little front end to encrypt and secure that transfer of the file, even within the protocol itself. So yeah, protocols are everywhere. Like another example, we use what's called RTP, real-time transport protocol. This was developed back in the days when video conferencing was new. They needed to have a way of communicating video data in a different carrier. So imagine video is important not to be disrupted. So they created a real-time transport protocol, RTP. And then later, again, because of the AV industry, we like to control things, think of it that way, right? We added what was called RTSP, which is real-time streaming protocol. This was the mechanism by which, through an RTSP, we could reach from the recipient, say you could reach back through the system and control the device that you were communicating to.
Like on my Netflix box, I'm watching something and I hit pause. It doesn't pause it locally.
No, yeah, absolutely. It actually pauses the server that's giving you the data. So that's why you can do certain functions, like you could pause, fast forward, rewind. You're not doing that locally. You're doing that actually upstream to the device you're communicating to. So like I said, there's protocols about all over the place, all the way down into, like I mentioned, having the RTP. There are different types of ways that we communicate, right? So what we had from original days, we were able to do, and part of the communication, what we're talking about, Ethernet, was TCP IP. Those are actually two protocols that we link together. So TCP is Transmission Control Protocol. And what we use TCP for is it's kind of what we're doing right now. It's a two-way conversation.
Yeah, I always thought it was like a handshake negotiation.
Yes, it's a handshake negotiation. It's kind of a three-way. What we're doing is we're acknowledging, like, so I'll ask you a question, you'll respond back. I'm waiting for that acknowledgement. So if I send you data through TCP, I'm waiting to acknowledge, not necessarily waiting, but I'm acknowledging that you received that piece of information. This basically creates the two-way unicast style of communication. What is unicast? It's a one-to-one relationship.
Yeah, and you gain reliability with TCP, right? You can re-request something. It gets lost on the network. The packet gets dropped, whatever. I can go, hey, I missed that bit, and you can give it back to me, right?
Absolutely. And that's, like you said latency, right? Yes, we increase latency when we're doing that because the process of acknowledging that you got the data and if you didn't, it now means I need to transmit it. Now, as you can see, that is a two-way communication. I got stuff going on. That might not be appropriate for all types of communication.
Yeah, so like we're moving to UDP here, which is more of like a broadcast, right? I wouldn't want that heavy negotiation in that process.
That's correct. Like for the reason we use another form of transport called UDP, User Datagram Protocol, is because we don't rely, or let's say validating that you got the information isn't as important as getting it to you as fast as possible.
Yeah, because if I was watching a video stream and I missed a frame of an image, I don't care about it because I've moved past it.
You're past it. Yeah. In fact, it would be a little bit odd if you're like in the middle of watching something, you get frames from video that didn't get to you. It would be weird for the user to see that happen. And quite honestly, we were talking about AV over IP using what's called multicast. Multicast leverages user datagram protocols. And as you said, it's kind of like a broadcast. Well, user datagrams don't really care about the destinations. It could be everybody. And that's where multicast comes in. We use UDP along with multicast to distribute AV, whether it's audio or video, from a source to one or many recipients. And it uses this protocol as a delivery mechanism.
Yeah, and we just kind of then leverage other feature sets like IGMP to limit where it actually goes.
Yeah, and as you just mentioned, IGMP. Well, IGMP is another protocol that we would use when we are trying to manage that type of delivery mechanism through multicast. So IGMP uses a system of creating what we call multicast groups. So it's almost like, think of it like a radio station or a TV station. That data is there, and you want to tune into it. Well, it's IGMP, Internet Group Management Protocol, where the network electronics now manages and directs that data to you as the individual that wants to receive it. And it works also off of what the other part of that TCP, IP, the Internet Protocol, which we all know and love, is where IP addresses come from. And Internet Protocol is another protocol. It's the rule set. So as we talked about an IP address, the Internet Protocol is what defines that. It gives us our relaying datagrams. It gives us all of our routing and internetworking routing. It defines how the internet works, if you will, all of the interconnected networks. And it also is in tune with how we deliver packet delivery between hosts, and it governs the IP address. So we were talking about the IP addresses in the Internet Protocol, and then let's relay that back to the MAC address, because remember we have a physical identity and a logical identity. Well, there's another protocol that helps link those two things together. It's called Address Resolution Protocol. And what an ARP for short, what that does is if I go into a network with an IP address, remember I might have physically plugged into that network, and that MAC address is physically associated with the port on the switch. Well, ARP helps resolve the IP logical address to the actual physical connectivity on the switch itself.
Yeah, it's like a big table.
It is a big table. It's exactly that. So you'll see a big table if you were to, take the switch apart type of thing. You would see a big table that says this MAC address is associated with port 1 on the switch or wherever you happen to be plugged in. So an ARP will say, hey, I've got this IP address. Does anybody know where it is? And the switch will respond. It's associated with this physical MAC address.
All right. Well, this discussion's been very helpful. Thank you so much, Kevin.
You're very welcome, Kyle.
Please stay tuned for more videos from CTI.